This is Year 13 Physics AS2, and this question is from AS3 2007. Question 3. Figure 3.1, which is not to scale, is a graph of the log to the base 10 of I over I naught, plotted against sound intensity level measured in decibels. So you can see log I over I naught here and intensity levels in decibels here. Use the defining equation for sound intensity level to state the value of the gradient of this graph. So if we have a wee look there, our intensity level equation is equal to 10 log to the base 10 of I over I naught. Now we can see here that this is in the y-axis, so we need to make this the subject of the equation. So to do that, all we have to do is get rid of the 10. So intensity level over 10 is equal to log to the base 10 I over I naught. And if we then write down y, that's on the y-axis, mx on this side. On the x-axis we have the intensity level, and so therefore 1 over 10 is equal to the gradient of our graph. So the answer to the first bit then, what is the gradient of the graph? The gradient of the graph is 1 over 10. Possibly I'll just split this up a wee bit more. So it's IL, which is intensity level, multiplied by 1/10 is equal to log to the base 10 I over I naught. And obviously what we have on the x-axis is intensity level, so the gradient must, whatever's left there, must be 1 over 10. Explain why an increase of intensity of 4 by 10 to the minus 8 watts per metre squared sometimes leads to a very large change in intensity level, but sometimes in almost no change in intensity level. And the whole point about intensity levels are a ratio of an intensity to that reference value, and that reference value is 10 to the minus 12. So obviously, if the intensity that you are comparing to this is very large, then you're going to get a large change in intensity level. But if the intensity you're comparing to this is very small, then you're going to get not a very big ratio there. So you're going to get a large intensity level change if the ratio of the intensity to 10 to the minus 12 is large. But it's going to be a small intensity level change. And that's why, even though there may be a change, if you have if you have a very small change from, say, to the minus 10 to up to 6 to the minus, sorry, 2 to the minus 10 up to, that doesn't make sense. But, well, I'll just finish that off before I dig a hole for myself and just say it depends on how big the change is compared to the 10 to the minus 12. A crowd dispersal system generates a high-frequency sound, which is audible only to those of teenage years and above. This is called a mosquito, by the way, and you may have seen this article with me in class or in the paper or something like that. The purpose of this device is to stop groups of teenagers congregating in certain areas by creating an irritating buzzing noise. It's generally very high frequency, up near 20 kilohertz. The device is mounted on a wall, a distance of 1.2 metres from it. The intensity level is 75 decibels. Calculate the intensity of sound at this location. So if we write down our equation, intensity level is 10 times log to the base 10 intensity over 10 to the minus 12, or 1 by 10 to the minus 12. Rearrange that, you get 10 to the minus 12, well, intensity level divided by 10, and the inverse log of it. And then when you multiply over by 10 to the minus 12, that is how you calculate your intensity. And so if you put your numbers in there, the intensity is going to be 10 to the minus 12 times log to the minus 1 of 75 over 10. And that answer comes out to be 3.16, or we'll just round it up to two significant figures, so 3.2 by 10 to the minus 5 watts per metre squared. Because the device is mounted on a wall, the sound energy is spread uniformly over the area of a hemisphere of radius 1.2 metres. The surface area of a hemisphere is 2 pi r squared. Calculate the energy transmitted every second by the source of sound energy. Your answer should include a relevant SI unit. So if we calculate the area of the hemisphere, the area is 2 pi times, so the radius, if the source of sound is here, then out here, then the distance is, the radius is 1.2 metres squared. And we have to square it. So the area comes out to be 9.05 metres squared. Then intensity is power over unit area. But we know that power, we're looking for power then. So power is the intensity multiplied by the area. And the intensity we have worked out in this question above is 3.2 by 10 to the minus 5 multiplied by 9.05. which gives you 2.86 by 10 to the minus 4. Now that's measured, because it is a power which is in watts, 1 watt is 1 joule per second, and we have to get the energy emitted every second, so that's just the same answer, because it's within a second, it's every second. So it's 2.86 or 2.9 by 10 to the minus 4, and it's measured in joules then, because we know the question says energy emitted every second, so an energy is measured in joules.